guys, it's IDW, and today we're going to be finally finishing off this series, and we're going to be doing Carry-Look Everywhere edition, which is a special type of edition that's used in Redstone, sort of because you can't really build it in real electronics. But yeah, basically the idea is you're trying to make a more neat and more organized proper look-ahead adder that doesn't have wires going everywhere, that's systematic, basically. And yeah. On top of that, there's two other features that you generally have. One of them is that you try to reuse wires as much as possible, and the other is that you try to make it synchronized, just because it's just easier for certain things. And if you have something that's as organized as this, that is as fast as this, and has the option to be synchronized, then you want it to be, unlike the our older carry-look or ripple carry adders. But yeah, so that's basically what Carry-Look Everywhere edition is. It's just proper look-ahead edition with a few extra twerks. So yeah, so I technically will actually end up building a proper look-ahead adder. It's just going to be in the form of a Carry-Look Everywhere adder. So yeah, let's start to build this thing. It's a bit of a complicated build, the one that I'm going to be showing off, and it's a pretty standard one, made by MBZone. If you're watching this and you're like actually an advanced person, first of all, why are you watching this? This is for beginners, and second of all, you probably know exactly what design I'm going to be using. So yeah, see you guys when I start to actually build this thing. And before I actually move on to actually building the adder, I thought I might want to mention one last little thing, and that's actually a bit of a proof with adders, and that is that for some in an adder, we don't actually have to XOR, well, we don't have to AND to create this carry. We don't have to use the actual first sum. We can actually use the OR of the two inputs, and the reason for this is the only difference between an XOR and an XOR and a normal OR gate is that in an XOR gate, the output is off when both inputs are on. So if you think about it, what that means is that the only time that it's actually going to matter in terms of the difference, both of the inputs are going to be on. And that means that we're going to be creating a carry to go onto another bit. So basically, it won't actually matter whether or not we carry over. So this is something that we're actually going to be using in the adder that we design, so that we can actually take advantage of a few design. Well, basically, it just makes the design a whole lot easier because you don't have to make an XOR, and it makes it easier to synchronize it. And you'll see when we actually build the thing, but yeah. Now let's get over to building the thing. Alright, so I just off camera did a practice build, and I really whizzed through this, which is amazing because Carry-Look Everywhere adders are generally viewed as notoriously complicated, and you will mess up and you will completely screw up. But I'm sort of impressed that I managed to actually do it without really having to look at a pre-build like once, so I'm pretty confident right now that I'm going to be able to build this thing on camera. So yeah, basically we're going to start off with an OR gate. If you remember from the proofs that I just did, we don't necessarily need a NOR gate. To propagate the sums, you don't necessarily need a XOR gate. You can just use an OR gate. So yeah, I'm just going to use an OR gate first of all. Well, actually, only because I need that. I'm actually going to be able to make the NOR and AND that I need to make the XOR gate with just these guys. So yeah, basically what I've done right here is this design tiles diagonally, so it's really a complicated build. And by tile, I mean that if you were to like slash stack it with world edit, it would go diagonally up and not in an easy to do pattern. So yeah. Anyways, so this is where I'm going to have my AND gate right here for the first XNOR. And that's where that's going to be. And then I'm going to have my NOR gate be actually right here. Because if you think about it, ooh, yeah, I know, right? Thing is, we still have to power this wire right here, so the way that you do that is just like that. Pretty simple so far. So yeah, this is actually our first half adder. And I'm actually going to AND these two togethers to use for the carry generating thing. And yeah, so if we were to just look at this thing right here, what we have is our half adder. So if we were to OR these two torches together, this acts as an XOR. And yeah, actually it would be easier if I took a wire out like this to show this off. So yeah, both on, the output's on, one on, the output's off, that one on, both off, the output's on, only this one on, the output's off. So yeah, it's an XNOR gate, and that's an AND gate right there. Well, actually it's a NAND gate, because we're going to be using proper look-ahead addition. So we're going to be generating our carry with a NAND gate. So yeah, this is basically the first half adder finished. And this one tiles diagonally because it does need to for the carry logic design. The way that we're going to be managing this, well, the way that, you'll see. These things like this are easier to understand when you actually see them. And please, actually I shouldn't do it, actually I shouldn't stack it yet. You should actually only stack stuff like this when you've actually finished building two of these. I'm going to build the second one off camera. But yeah, make sure that you have a slab here and here and here. It has to do with tiling purposes. I'll show you why you need all those in just a second. But yeah, see you guys in a second. And this might be coming out in an episode or two, by the way, just because it's so complicated. Alright, so now those three places where I showed you the slab, there, there, and there, now we're going to see why we need them. We need a slab there so that that signal can actually travel up. We need a slab there so that that can go into there. And we need a slab here so that it doesn't get powered by that torch. So yeah, see how this thing stacks diagonally? It's really, really, really annoying. Anyways, if you wanted to stack something diagonally like this, it's best to make the bit before it, before you actually make, well, before you actually stack something. So basically just, I copy this from here, and all the parts where it like crosses over itself, well, not technically there, I guess, because it didn't really paste that, but all the places where they sort of intertwine with each other and don't conflict, it'll do the way that you want to do it. So that right now you have 3 bits, 4 bits, and sure, I'll make a 4-bit. In my, whoops. So yeah, there you go. We have 4 bits of an adder. Originally I was thinking I would do an 8-bit one, but hey, it doesn't really matter. Anyways, so the next step, and I actually didn't do this on these guys, which I should have, is first of all to block these guys off if you didn't already. And then second of all, add redstone right there. And so now we're going to be using a NOR gate like this. And since we're using a slab, the signal can't flow down. So if we were to attach a redstone torch right here, then this would just be the AND these two bits. And then if we were to attach a redstone torch right here, it would be the AND of just this bit. So the sum of this bit and the AND of these two bits, and it would just keep on going all the way up to the top. So yeah, I think I'm going to build the carry line off camera, but I think this is also where I'm going to cut the video, just because I think I might be running out of time at this point. So yeah, hope you enjoyed, and see you in the next video where we will actually finish this whole thing off. Bye!